Scalar product of two vectors. First of all, the word scalar. What does scalar mean? Well, not a direction. Scalar is just a number. So the scalar product is some sort of product of two vectors which just returns a number. If I show you how to do it, it's very, very simple. Let's have vector A being 2, minus 5, 6. Let's have vector B being minus 5, minus 1, 0. If I want to do the scalar product, this is the notation I use to write it down. A dot B. And you may have the wavy lines under that. But that dot, and you actually read it like that sometimes, you might say A dot B. That's how you might read it. That's the notation for a scalar product, putting that dot between them. This is how you work out the scalar product. You do 2 times by minus 5. That's that 2 and that minus 5 times together. Then you do minus 5 times by minus 1. So I times the top numbers in each together. I times the middle numbers in each together. And now I'm going to times the bottom ones together. 6 and 0. And I'm going to add those numbers up, those answers up. Minus 10, 5 and nothing. Add that together, I get minus 5. That is how you work out the scalar product of a pair of vectors. That's an example with numbers, isn't it? Yep.
So what is that number?
We're going to use that number in a minute. We're going to use that number in a minute. It's something that's going to help us to do something else. If you remember the heading we started with today, or what was on the board rather at the beginning, was being able to find the angle between two vectors. We're going to use this in a minute. You're going to have a red box rule which is really key to this chapter, and it will involve these things. It will involve the scalar product and it will involve the modulus, and we'll then be able to work out the angle between vectors. If our vectors had been x1, y1 and x2, y2, and I'm doing the scalar product of those, so there's one vector dot another vector, what would the scalar product of those be? Yeah. Yeah. So if you want a sort of a rule of what you do, yeah, you just times the x's together of each of them, you times the y's together, you add them together, and you can extend that to 3 dimensions. If there had been a z at the bottom, then you just had a z1, z2 times there as well. Okay. Can anybody just have a little think a minute? If I had asked you to do A dot A, so the scalar product of A and A, where that was A, and I'm scalar producting it with itself. Anybody think of anything that's going to happen here? Or how it might be related to something else we've looked at? What will I do here? What will the sum be that I do to do this dot that? Right, what have you just said, Gavin? Well, it'll be 2 times by 2. It'll be minus 5 times minus 5. It'll be 6 times by 6 added together. Is that like anything we've seen? Yeah. If I square rooted that, that would have been the length, which we called the, not magnitude, the right first letter, modulus, yeah. Okay, so that is the same thing as the modulus of A, all squared. Okay, so if you dot something with itself, you're actually finding the square of the length of that vector. Right, that's our preparatory sort of work out the way. We can come on now to the main bit about the angle between two vectors.